Hi everyone, today we're working on Unit 4, Lesson 11. We skipped a few more lessons, that way we can wrap up Unit 4 before we go on winter break. Today we're going to be working with area models for rectangles and rectilinear figures. Our objective is to find the area of rectangles and rectilinear figures using multi-digit computations. Before we get started, please make sure that you have your everyday math journal and a pencil. I want you to start thinking about what's the formula for finding the area? How do we find the area? So hopefully you said that the formula for finding the area of a rectangle is length times width. Today we're going to apply our ability to find the area of rectangles to find the area of more complex figures, like the one shown below. You're going to use your knowledge that area is length times width to be able to find the area of more complex figures. So as our warm-up, I want you to turn to page 135 in your math journal, and you should be able to do problems 1 and 2 on your own. These problems are involving just the normal area of what we've been working with all year. So I want you to pause your video and go ahead and find the area of these figures. Do that now. All right, so let's check your work here. I hope that you said the equation for finding the area of this shape would be the length times your width. So that means that we would be doing 25 times 15, and that would give you your area. When you do 25 times 15, you should get an answer of 375. I could use partial products to solve my answer here. First, I would do 10 times 20, which gives me 200. Then I would do 20 times 5. Oh, I can't forget to write this down here. 20 times 5, which gives me 100. Now I have 5 times 10, which is 10, sorry, not 10, 50. And then I have, last but not least, 5 times 5, which is 25. I need to make sure that I add those numbers up, and I would get an answer of 375, which goes with the answer that I told you. That should be nothing new. Length times width equals your area. Number 2 says a science table needs to be covered with plastic for a messy experiment. The table, I'm going to go ahead and draw a picture here. The table is 25 inches wide and 38 inches long. So I'm going to circle that. How many square inches of plastic do we need? So we're trying to figure out, let's pretend that this green here is going to be my tablecloth, and it's going to cover the whole table. To be able to figure out how big that tablecloth needs to be, I can use my knowledge of area to figure out how much space does that inside green cover. I would do 25 times 38 to find my answer. And I meant to write that up here. And then I can use multiplication to solve and find my answer. When you do that, you should get an answer of 950. I can show you my work to prove that the answer is 950. So what I'm going to do is I'm going to start with 38 times 25, and I might run out of room here, so I'm going to actually restart and do it over here on the left in red so that we have enough room. 38 times 25. So first I'm going to start by doing 30 times 20 because I have 3 times 2 and they're both in the tens place. So that gives me 600. Then I'm going to do 30 times 5, which gives me 115. And I'm going quickly on this because you should have already solved on your own. I'm just showing you in case you didn't get the answer correct. Then I have 8 times 20, which gives me 160. And then I have 8 times 5, which I know gives me 40. When I add these together, I'm going to get 950. Okay? All I did was do length times width equals my area. So now I want you to take a look at these two shapes. How are they different? How are they alike? How are they different? How are they alike? The first thing that I noticed with them being different is in the first shape, 5 times 20, that's what we've seen all along. It has 4 sides, 4 angles. It's just a regular rectangle. And the figure below has 6 sides, and they're all different measurements. But the thing that I noticed is alike, that they all have right angles, just like the traditional rectangle up here. And I also noticed that if I split that shape up into 2 parts, if I partitioned it, I could make 2 rectangles. So, how do you think we could find the area of the complex figure? Remember, that goes back to our objective of finding the area of more complex rectilinear figures. What do you think I could do? Do you see a way that I could split that shape up so that I have 2 rectangles? There are a couple different ways. So I'm going to show you here. We could split this shape up 2 different ways. The first way, I could draw my line here, and now I have 2 rectangles, right? And on the inside of this box, my length is 10, and my width here, notice it's just 4. It's not 6 because this whole line is 6. So the inside of my box here is 40. Then in the other rectangle, my length is 7 and my width is 2. What do you think I would do with those 2 numbers on the inside? We'll come back to this in a little bit. So this is a rectilinear figure. It's composed of a number of adjacent rectangles, meaning rectangles that are next to each other. Remember, a rectangle has 4 sides, 4 right angles, and 2 sets of parallel sides. So when we find the area, it doesn't matter how complex the rectilinear shape might be, as long as we can divide it into smaller rectangles or squares. So when you see a complex figure, you need to try to figure out how can you divide it up into smaller rectangles or squares, and that will help you to be able to find the area. So I kind of gave you some hints on a few slides ago, and I showed you a way that you could split the complex figure up into 2 smaller rectangles. Do you remember what that looks like? Okay, so I showed you earlier that we could split it up into 2 rectangles this way, but now I'm going to show you another way. Some of your brains may have already thought of this. So now I have 7 times 6 in this box, and then over here I have 3 times 4, which is 12. Both ways will give you the same answer. And the next step, what I would do with those circled answers here is I would just add them together. 42 plus 12 gives me 54. I want to show you on the other way here. I got 14 and 40 inside of my boxes. Is my answer the same, both ways that I split them up? Yeah, so both ways are correct. They're just different ways of writing it. As long as you came out with 54 being the area, you'd be correct. All right, so this might be a little bit tricky since I'm writing on a screen and you don't have this right in front of you, but I want you to copy this picture down onto your slate. Copy it down and make sure you write the measurements. Then I want you to find the area. So you're going to have to partition the rectangle, split it up into two smaller rectangles so that you can find the area. So the easiest way that I see to split this up, my brain saw it this way. And inside I would write 8 times 5, which is 40. But I have to be very careful with my other piece because I don't know the width here. There's a way for me to be able to solve though. I know that my whole length here, or width, is 6, and I know that this chunk, which stops right here, is 5. So that tells me that 6 minus 5 will give me that chunk right here, which is 1. So then inside I'd have 3 times 1 is 3. So your total area is 3 meters squared. Your brain may also have done it this way. Maybe you decided to split it this way, and inside you have 6 times 3, and you said that was 18. But then over here, it's 5 times, it's not 8, because 8 is from here to here. But we know that this chunk is the same as this chunk, which is 3. So 8 minus this chunk here will give you the length. 8 minus 3 is 5. So right here is 5. 5 times 5 is 25. 25 plus 18 gives you 43, which is the same answer as the first picture. So this one was a little bit more complex than some of the other ones that we've seen. So now I'm going to have you go back into your math journal, and we're going to do problem number 3. The directions say study the figure below. It is a plan for the new computer at Pond Cove School. The school's principal needs to determine how much carpet will be needed to cover the floor. Covering the floor tells me we're going to be finding the area. A says find the area of the room. Show your work below. All right, so when I look at this figure, can I just right off the bat find the area? No. I'm going to have to split it up into smaller chunks. So what I need you to do right now is you're going to split this into chunks like this. In my box right here, I know my length and my width are 5 and 5. So 5 times 5 gives me 25. What about the green box? What equation would go inside of there? I hope that you said 5 times 4 equals 20. But now I have to figure out this bottom larger purple rectangle. For this chunk, I know the length is 14. But do I know just this part of the width? I know that from here to here is 10 feet. And I know that these sides here are the same, and so this is 5 feet. and this part right here is 5 feet. So if my whole line is 10 feet and one chunk of it is 5 feet, the other chunk must also be 5 feet. So 14 times 5, I'm going to have to do partial products to be able to figure that one out. I know I have 10 times 5 and 4 times 5. So my answer here is 70. So now on the inside, I'm going to have to add up all of those chunks to be able to get my answer. So when I add 70 plus 25 plus 20, I get an answer of 7 plus 2 is 9, plus 2 more is 11. So I get an answer of 115 square feet. My equations here that I did 5 times 4 plus 5 times 5, that was the red box, plus 14 14 times 5. And that gave me my final answer. I'm going to go back over these with the colors so that in case you're confused, you can refer back to them with the pictures of the boxes. Alright, so then the other part B of this problem tells us that we need to find the perimeter. So when I find the perimeter, I'm going to go ahead and erase all of my work from the area because I need to be able to see better. How do you find the perimeter? You add all the sides. So if we add up all of our sides, let's start with the longest part, 14. I want you to trace the line after you've counted it. 14. How long is this side going to be? We know it has to be 10 because it matches the 10 feet that's parallel to it. Plus 5, plus 5, plus 5, plus 5, plus 4, plus 10. We add all of the sides up, and that gives us our perimeter. When we add those together, you will get an answer of 58 feet. So there really weren't that many problems for us to do today in our math journal together, but the point of this lesson was to expose you to the idea of additive area. When you partition a rectangle, you make it into smaller rectangles and squares to be able to find the area. So I would like for you to be able to see if you can solve this one on your slate and come up with an answer. And I'm going to have you submit your answer to this problem in Canvas today. So I hope that you're still listening to the video because I'm going to have you submit your answer to this problem number 1, in Canvas. So you're going to do that one on your own. So I would copy this down into your journal or into your whiteboard so that you can draw the lines and figure out what the area is combined. Then you're also going to, so this is on Canvas, then you're also going to do your math box for 11. So for 56, to be able to figure out all the factor pairs, I want you to draw a factor rainbow. For box 1, you need to make sure that you do cubes. And for your answer to be reasonable in problem number 1, remember, If your actual answer is close to your estimate, then your answer is reasonable. It makes sense. So don't forget about that question in Canvas. You also need to do extra math and whatever else your teacher has assigned for you to do in Canvas. Have a great day.